South America. Deep in the mountains of Colombia. January 2018. The two separate towers would soon be joined by a concrete span. Until disaster strikes. One of the bridge towers fails and falls 900 feet into the gorge below, taking with it the lives of 10 construction workers. 62 miles from the city of Bogota, the mountainous region of the Andes, the bridge was being constructed in the municipality of Guayabetal. The country needed to update infrastructure. Billions of dollars were spent on modernizing transportation networks. This meant building things like the Chirrahara Bridge, a nearly 1,500-foot cable-stayed bridge that would connect the cities of Bogota and Villavicencio. This area of the country is a natural wonder. The road, a scenic ride through the mountains. This peaceful setting was interrupted by the rumble of the bridge falling. What is a cable-stayed bridge? To support the weight, cable-stayed bridge design uses vertical towers. The cables are attached from the towers and extended to the deck level, forming the famous triangular shape and some of the most iconic marvels of modern bridge building. Want to travel from Kentucky to Indiana? Take the sprawling William H. Natcher Bridge, which stretches over the Ohio River. X marks the spot with the Octavio Frias de Oliveira Bridge. This 5,200-foot bridge is located in the southwest side of Sao Paulo, Brazil. The Fred Hartman Bridge is the longest cable-stayed bridge in Texas. Even after 30 years in operation, 200,000 vehicles still cross it every day. The cable-stayed design is unique in how it deals with the forces of a bridge. The namesake cables are attached along the horizontal span and connect to a tower, which absorbs the compressional forces and bears the weight. Plus, fewer materials, more prefabricated elements like concrete sections, and faster construction times make cable-stayed bridges cheaper to build. There's a delicate balance between the towers dealing with the downward compression and the cables maintaining tension. When that balance is off, disaster can strike. The Chirrahara Bridge had two towers, one on each end of the valley. The towers were being built simultaneously, and the 940-foot span was going to meet in the middle. They had 164 feet to go. When completed, the bridge would include 2 vehicle lanes and 2 pedestrian walkways. But no cars or people would ever get the chance to cross the bridge. At about noon on the day of the collapse, a traffic camera captured the catastrophic fail. The tower on the western side fell into the valley below. So what went wrong? Research into the collapse revealed the failure was likely there from the beginning. A design error. A fatal flaw. The tower legs did not have enough reinforcement built between them to support the required load. And if the tower legs couldn't hold up the load, other parts of the tower structure will try to resist those forces. Parts that were not equipped to handle it. The fail started with the crossbeam, where the lower part of the tower met the horizontal span. Under the span, the reinforcement of the diaphragm was supposed to resist the horizontal tensile strength of the tower. Once the tower started to collapse, the forces fell to the diaphragm and the lower legs, which couldn't carry the load. At the time of the collapse, the bridge was not operational, but there were people working on it. The 10 victims were construction workers. 9 died at the accident site, and a 10th later in hospital. In the wake of the collapse, attention turned to the tower that was still standing. On closer inspection, cracks were discovered on the diaphragm and the lower leg. Worries grew that the standing tower would suffer the same fate as the ones strewn across the valley. it couldn't be salvaged. So, 220 pounds of explosives were used to demolish the remaining tower. Time to go back to the drawing board. Start over. A complete redo. A totally different kind of design. The new bridge is a box girder structure and was ready ahead of schedule in December 2023. Elevated highways are built above the ground for long distances. The design allows them to physically be above what might slow down traffic on a regular road. These highways are usually part of a larger transportation system in cities that includes local roads, overpasses, and other bridges. They connect neighborhoods from downtown to the suburbs, get people where they need to go faster and more efficiently. But when they fail hard. Thailand. Famous beaches and famous traffic jams. Traffic congestion in Bangkok is among the worst in the world. One solution to these traffic woes: elevated highways. The only trick is to keep them standing up. In the span of 3 months, 2 elevated highways collapsed in the city of Bangkok. Rama 2 Road is one of the country's major highways, an essential link between Bangkok and Thailand's southern provinces. This road was constructed in 1970. It's nicknamed the Endless Highway, and that's not being poetic. Road repairs and upgrades are ongoing and keep going, endlessly, for decades. Expanding highways like Rama 2 Road with more lanes only means more cars and more traffic. To help ease this traffic gridlock, a 10-mile elevated highway was being built. On May 7, 2023, at about 4:15 p.m., a precast concrete slab seemed to fall from the sky. One construction worker was killed and another was injured. Plus, lots of damage. After all, this piece of concrete weighed several tons and was over 30 feet long. Afterwards, an inspection by the Expressway Authority of Thailand found the main problem that contributed to the accident. The post-tension bar material used to anchor the slabs was defective and couldn't support the weight of the bridge segment being lifted. These post-tension steel bars are used to temporarily stitch the precast slabs together. The bars are able to support heavy loads due to high tensile strength, even loads weighing several tons. These bars temporarily connect the slabs of the concrete and then are replaced by post-tension cables that run from one end of the bridge to the other. So, when the ribbon is cut, the elevated highway is much more solid. Reusing the steel bars is common, but can cause fatigue or flaws once it's put in place. A broken PT bar was found at the site of the accident and sent for testing. The inspectors also flagged another issue: human error. Proper work procedures were not followed. Witnesses watched as the sling being used to lift the concrete snapped, and the concrete slab fell to the ground. The inability to follow proper construction procedures, along with potentially defective PT bar material, is likely how the concrete slab ended up falling. In the wake of this accident, the Expressway Authority of Thailand and the Department of Highways put together some new short-term safety measures. Safety measures are way overdue. Rama 2 Road is considered one of the most dangerous highways in the entire country. This isn't due to vehicular accidents, but the ongoing construction. In 7 years between 2018 and 2025, the Department of Highways reported more than 2,500 construction-related accidents.